Hi, this video is to talk about the interval estimation when we don't know the population standard deviation. Again, what we're doing is building an interval that might include the population mean using the sample data and the sample standard deviation. Okay, so let's discuss some of the concepts. In this case is known as the standard deviation unknown. I like to say when we don't know the population standard deviation. It's easier for me, okay? So when we don't know the population standard deviation, that's in most cases, then we use the sample standard deviation. So we get the sample, we compute the mean, and then we compute also the standard deviation, and they're going to be using the standard deviation as an estimate of the population standard deviation. In this case, we lose 1 degree of freedom to compute this the sample standard deviation, and because of that, we have to use a t-distribution, not the normal distribution or the standard normal distribution, which is the z-score distribution, but the t-distribution, okay? And then the formula to build the interval estimate is the same. It's very similar because we have the sample mean and we add and subtract a margin of error, and this margin of error is composed of the standard deviation of the sample mean, which is computed using the sample standard deviation divided by the square root of n, and a t value. Instead of a z value, we use a t value based on the confidence level, based on the alpha level divided by 2, as you know from other videos, okay? So the only differences we have from the other formula to compute the interval estimation for the population mean is that now we're using a t instead of a z, and we're using the sample standard deviation instead of the population standard deviation, okay? So let me go ahead and talk very quickly about the t-distribution. The t-distribution replaces the normal and the standardized normal distribution. So we're replacing the z-distribution by the t-distribution, okay? And this t-distribution depends on one parameter, which is the degrees of freedom. The degrees of freedom refer to the number of independent pieces of information that go into the computation of the sample standard deviation. More directly, we have to compute the degrees of freedom by by subtracting the sample size minus 1. That's what degrees of freedom is, okay? And this is to show you that we can have different shapes for the t-distribution depending on the size of the population. Look, the degrees of freedom is a function of the sample size. The degrees of freedom depends on the sample size. So if we have different sample size, the distribution is a little bit different, okay? Because the resulting degrees of freedom is different. That's the idea here. And how you compute the t-distribution, or the t-scores, the t-values from the t-distribution using Excel. So this is how you do it. First, you have to compute the alpha level like we had before. That's 1 minus the confidence coefficient. We divide the alpha level by 2, and then we subtract 1 minus the alpha level divided by 2. And here are the formulas, and we use this resulting number. We plug it here in the function equal t inverse open parentheses. We get this resulting number and plug in here, and then comma, and we type the degrees of freedom. So let's do this example in Excel so you can see how to find it, okay? So let me type, we have a middle in the middle. We have a sample size of 19, okay? 19 observations. So I compute the degrees of freedom. The degrees of freedom is equal to the sample size minus 1. It's done, very simple. And now we have the alpha level. Let's say the alpha level in this case is, let me start with the confidence level. So let's say the confidence level is 95%. The confidence coefficient is 0.95. Oops, it's 0.95. And then the alpha level is going to be 1 minus the confidence coefficient, alpha level divided by 2. Remember, we divide the alpha level by 2 because the distribution has 2 tails. That's the reason we divide. So we get this number divided by 2. And then we subtract 1 minus alpha level divided by 2, which is equal to 1 minus this number here. And now finally the t-value or t-score, which is equal to t inverse, open parentheses, and then the probability, which is this one, degrees of freedom is this one, okay, 2.101. 2.101. Another way, let me do that. A second way of finding t. So a second way of finding t is equal using this formula, t inverse 2t. Okay, in this case we use the probability, the alpha level, before dividing by 2, because this function has already the 2 tail included in it. Okay, so if we use this formula instead of this formula, you don't have to divide the alpha by 2, and the degrees of freedom is 18, and that's the same number. Okay, so 2 ways of computing the t-value. I'm going to stop here and prepare another video about the application.